Clearly, I need to learn to be more specific when I do these episodes. Every time I open my mouth, I need to prepare for the collective imagination of the viewers. We did a whole video about the biggest things in the universe and identified superclusters of galaxies as the best candidate. Well, the part of superclusters actually gravitationally bound enough together to eventually merge in the future. But you had other ideas, including dark energy or the universe itself as the biggest thing. Even love. Aww. One intriguing suggestion, though, is the idea of the vast cosmic voids between galaxies. Well, is the absence of a something a thing? It's time to go back to art school and talk about negative space. Oh well, who cares? Super interesting topic, so let's go ahead and talk about voids. Now, when most people imagine the expansion of the universe after the Big Bang, they probably envision an equally spaced smattering of galaxies zipping away from one another. And that's pretty accurate at the smallest scales. But at the largest scales, when you can see billions of light years in a cube that fits on your computer screen, then a larger structure starts to take shape. It looks less like an explosion and more like a tasty, tasty sponge cake with huge filaments, walls, and the vast gaps in between. And the gaps, the voids, the super voids, are the point of today's video. But to understand the gaps, we've got to understand why the universe is clumped up the way it is. Now run the universe clock backwards, all the way to the beginning, to a fraction of a second after the Big Bang, when the entire cosmos was compressed down into a tiny region of superheated plasma. Although it was mostly uniform in density, there were slight variations, quantum fluctuations in space-time itself. And as the universe expanded, those differences were magnified. What started out as tiny differences in the density of matter at the smallest scale turned into regions of higher and lower density of matter in the universe. And here we are, 13.8 billion years after the Big Bang, and we can see how the microscopic variations at the beginning of time were magnified to the largest scales. Instead of individual galaxies, we see huge walls containing thousands of galaxies. Filaments of galaxies connect in nodes. These structures are huge, hundreds of millions of light years across, containing thousands of galaxies. But the gaps, the voids between these clusters, can be even larger. Astronomers first started to think about these voids back in the 1970s when the first large-scale surveys of the universe were made. By measuring the redshift of galaxies and determining how fast they were speeding away from us, astronomers started to realize that the distribution of galaxies wasn't even. Some galaxies were relatively close, but then there were huge gaps in distance, and then another cluster of galaxies collected together. Over the last few decades, astronomers have built sophisticated 3D models that map out the universe at the largest scales. The Sloan Digital Sky Survey, updated in 2009, has provided the most accurate maps so far. The Large Synoptic Survey Telescope, destined for first light in a few years, will take this to the next level. Now, the largest void that we currently know of is known as the Giant Void. Original, I know. And it's located about 1.5 billion light years away. It has a diameter of 1 billion to 1.3 billion light years across. Now, to be fair, these regions aren't completely empty. They just have less density than the regions with galaxies. In general, they've got about 1/10 the density of the matter that's average for the universe, which means that there's still gas and dust in these regions as well as dark matter. There will still be stars and galaxies out in the middle of those voids. Even the Giant Void has 17 separate galaxy clusters inside it. Now, you might imagine continuing to scale outward. Maybe you're wondering if this spongy distribution of matter is just the next step in an even larger structure, and so on and so on. But it isn't. In fact, astronomers call this the end of greatness, because it doesn't seem like there's any larger structure to the universe. As the expansion of the universe continues, those voids are going to get even larger. The walls and filaments connecting the clusters of galaxies will stretch and break. The voids will merge with each other, and only gravitationally bound galaxy clusters will remain as islands, adrift in the expanding emptiness. The full scale of the observable universe is truly mind-boggling. We're here in this tiny corner of the local group, which is part of the Virgo supercluster, which is perched on the precipice of vast cosmic voids. So much to explore. So let's get to work. We've talked about supervoids, But that's really scratching the surface of the large-scale structure of the universe. What else fascinates you? Let me know, and I'll turn it into future episodes. We've talked so much about supernovae, but never regular novae. What's the difference? Find out in our next episode. Oh, make sure to stick around for the blooper. A big thanks to Sergio Botero, Minyan Chang, Matthew Anderson, and the rest of our 624 patrons for their generous support. If you love what we're doing and want to help out, head over to patreon.com/universetoday. We've talked so much about supernovae, but never regular novae. Duvet? Go back?